Hello and welcome to this talk about building data-driven AR apps with GraphQL. And a little bit about myself, because I didn't have this short video at the beginning. So my name is Vladimir Novick, and I'm developer advocate at Hasura. I'm also a consultant, so if you have questions and you want me to consult you on something, just reach out. I'm Google developer expert, author, as I mentioned, consultant, and I do a bunch of things in web, mobile, VR, AR, and IoT. Honestly, I want to get also into AI and blockchain to be on top of buzzwords. And well, usually I used to say that I even have stickers of that I'm kind of building a cyberpunk future in a good way. So if you want these stickers of building a cyberpunk future, welcome to get them. So today we'll talk about Reality 2.0 version. Well, we call it actually augmented reality, right? Because this is the where our humanity will go eventually. But before talking about how we will create this AR apps, how we will consume this AR content, let's talk about how it all started. Yell out the year that you think was the first mention of AR. Come on, just be more active. Yell out the year. 1905. Beginning of 20th century, there was a book, Master's Key. I don't remember the name of the book. This is funny, but the thing is, the book is from the author of Wizard of Oz, and it talked about this character marker that was above each person, and it just meant if a person is bad or good. This was the first mention of AR, and obviously the actual AR development started around 60s. And there was a device called Sword of Damocles, which was a really nice device. This is how it looked. So the reason why it was called so, because this thing over there weighed around 4 tons. So if it will fall on this guy will die. So that's why there was the name Sword of Damocles. Then it continued to bunch of people sticking their face into machines. There was also like AR, VR-ish thing. Continuing on in 70s, 80s, when people tried to embed AR into military, but technology was not there. So basically, this helmet this guy has, this is 2 cameras that are mounted on robots, and they transfer video streams to his eyes, and he, with huge lag, he sees sort of AR content. And some people don't know that Google Glass started with iTap, and this looked kind of weird, kind of tag. Also, the guy is not. I don't know. This is the photo I found. But yeah, eventually it evolved to Google Glass and a bunch of AR content on these semi-transparent or transparent screens. Recently, well, 4 years ago, something like that, there was introduction of Microsoft HoloLens, which is how many of you have heard about Microsoft HoloLens? Cool. How many of you have actually tried Microsoft HoloLens? Nice. So the ones of you that tried Microsoft, the ones of you that haven't heard, it's like a device that you put on your head, looks like VR headset, and it produces AR content into the real world. And commercials are great. They look like this, right? Like this guy, and everything is amazing AR content in the world. But the ones that actually tried that knows that that is how it actually looks like. So you have a tiny rectangle in front of you, and inside AR content is rendered. But we're almost there. We're almost there to have commercial stuff for AR. And the best device right now to use with AR is our phone, because we don't have this tiny field of view. We know we're inside our phone camera, so we are fine with not seeing everything in AR. We are fine to see AR only on our screen because we hold it in our hand and just walk around. Yeah, it's sort of bunch of weird places where you can find Pokemons, or you can mount your phone on guns and just run across malls and shoot at random stuff. But yeah, we almost there. The problem with AR is, yeah, 20 years ago, haven't heard about putting some stuff in front of our faces that it will be actually a thing, and now, uh, not also speaking about all of these like radio frequencies that go through our brain, and but we see cool content, and we're fine with that. We're fine with that, even if it's bad for our eyes, right? And AR, the actual use case for AR is it's just a funny picture, right? We don't actually use AR for just putting making roads better in Texas, right? But we use AR to augment our world with content. That's the major point, right? And this is not only for fun, but it can be really useful. So the question is how we can create AR apps today. There are a bunch of solutions actually, and the first common ones that you go to when you Google AR and how to start with AR, you see Unity and Unreal Engine, which are gaming engines, and they give you an ability to create things with AR, with ARKit and ARCore libraries introduced on iOS and Android. Inside the game engine, so you have all the physics and collisions detection and everything. You can write everything in engine, everything works. Amazing. You have also Vuforia, which is something that is used for recognizing AR markers. Now, markers is a concept of taking something, an image of sorts, scanning it, and getting AR content on top of this image. So Vuforia engine gives you an ability to do so. But today we will talk about something different, something more targeted towards either mobile developers or front-end developers, in the sense of either it's Android Java or it's React Native. And more specifically, I will talk about React Native and how you can do this AR content with React Native. How many of you have heard about React Native? Cool. How many of you are using React Native? Okay, so React Native in a nutshell is a framework that gives you an ability to write React code, which goes through the bridge and render as native views on your phone, whether it's iOS or Android. And it supports both. The code that will be rendered can be customized even with the native side. You can write Objective-C and add it to React Native, or you can write just plain JavaScript and React and get native views render. This is in a nutshell. So what Vero React has, it has real-world 3D tracking, surface detection. I can actually detect that this is a floor, and this is a desk, and this is a chair, and I can get the recognition of these markers of any image, actually. And recently, you even can, with the ARKit, you can recognize 3D objects. So let's say you have a can of soda, you put your phone camera on can of soda, you know that this is a marker, and you can render any content with that. Now, the renderer is really powerful, and it leverages ARKit and ARCore for rendering stuff. And we have real-world effects like physics, can have particle effects, and various stuff like that. So I prepared a bunch of demos for you. So let's see it in action. Let's open my phone, and I hopefully won't get awkward messages during the demos. So cool. So this is the phone. I will have a selection of AR or VR. I'll selecting AR. Oh, it's snowing. So this is the particle effect. You see, right? So it's this is you, and it's a bit chilly, but it's not only a thing that I can do. Hopefully, with the amount of light, I will be able. Yeah. So you see this gray rectangle. So this gray rectangle means that I can recognize the surface that is something there. I can put something on this rectangle. Oh, yeah. So this guy is. He looks offensive. He is not really. So don't be scared. But this is like the AR content in the real world. Now you can notice there is a shadow of this guy. He's moving, so I have skeletal animations of this 3D model, and it's snowing, and yeah, this is kind of nice. So let's get back here. Now, what was that? The empty slide. Ah, yeah. If this thing will load, I also have a video of another demo, which is not loading for some reason. Wi-Fi connected. No, no, that's fine. I guess we'll get back to it when it will load. So, yeah, still not there. Whoa. Okay. Oh, fine. Again, it gives me the bad thing. Anyway, so how do I create AR apps? Let's start with the basics, and basically we'll start with the app structure and how the code for this demo app with the monster looks like. So, to get started with Vero, with the framework itself, you need to go to veromedia.com and get an API key. It's free. You need just to sign up, put your mail inside, and get the API key. Now then you install Vero CLI package to basically have this CLI, and you initialize your app. Your initialized app is using React Native, not the latest version, but I think one version back. And the anatomy of the app, if this won't load, I will just... No, I still need the wireless, but we can do... I can actually do... yeah, let's do the hotspot, probably will be better. Sorry about that. Yeah. Okay, let's see. What's your... Yeah, but what's the name? Ah, okay. Let's see. Unfortunately, I cannot show. Let's wait until it loads. Sorry about that. Unfortunately, couldn't put it offline because of all of these online demos here. But okay, it looks faster. Oh no. Cool, there's actually the demo that I want to show you loads. So it looks like this. This is a casual game, basically a Tetris, sort of Tetris kind of game that you can create with Vero React. And getting back to the to the code itself, it looks like this. Loading, yeah. We have an app.js entry point, and inside we had a button, AR button, the one that you see on the screen when I click before loading the camera and the monster, right? Now then, we have a navigator. Navigator can define on which scene, AR scene I am right now, or VR scene, because Vero React supports also VR. Now the scene itself, you need to render everything on your screen into Vero AR scene component. And you have on tracking updated function, which is a callback that gives you a bunch of data on your physical world, on different parameters you maybe will need later on, and on type of tracking that you have. Now then, we have to define a bunch of lights. Now I will get for a second from get out from the code itself and show you the concept of the light. So there are several types of lights. The ambient light, the light that kind of wraps the whole scene and gives the color on every object. And there is a directional light. So this is Unity, by the way, so just more visual way to show you that. So directional light, if I enable it, it's like a sun, right? So this is the directional light. The point light is like a point in 3D space that projects lights in every direction. And a spotlight is kind of self-descriptive, and just a spotlight. So if I get back to my code, I see that the ambient light has a color and has an intensity. Now then I have a directional light with a bunch of data, how to create shadows, how to influence different bit masks, and it has a direction. Now everything in Vero React has a 3D vector of direction, and the important part is that it has x, y, and z, and z-axis is pointing, the plus z is pointing to the viewer. So if I want to present something in front of me, I will put it in minus z direction. So this is this sun basically is this direction light is going from the bottom up, right? So -1. Actually, sorry, it goes from up down because the direction is negative from negative y. So it's like a sun at noon, right? Now then, the spotlight has a bunch of data, inner angles, outer angles, stuff like that. You basically experiment with that to get the result that you want. Now you can present different types of text inside the app. Even you have Vero Flex View to present text aligned using Flexbox, which is nice. You use Flexbox in AR, pretty cool. Now to select my plane, when I put this monster on the monitor here, it was a gray rectangle. I use Vero AR plane selector to render my monster on this rectangle, and the monster itself had a Vero 3D object. Now 3D object can support three types of objects. VRX, which is a processed FBX file. FBX is one of the common 3D formats. It supports OBJ file extension and supports GLTF, which is kind of new file extension. Now here you see I have also animation defined. So I can define other animation that is skeletal animation, like this monster was just moving on the place, or I can define animation pretty much similar to how I define in React Native, so giving interpolations, giving like the easing values and stuff like that. We will see in a bit how it's done. Also, I need to define textures. And Vero also supports physical-based rendering, meaning I can define three textures: diffuse map, normal map, and specularity, which stands for color. Normal map is like how bumpy the surface is, and specularity is how shiny the surface is. Physical-based rendering, though, it's something different. It's like 5-6 different textures that give more depth to your model, and it also supports that. I told you about the animation, and I can render just quads or planes and basically whatever I want in this 3D world. Now I can create different materials like ground and so on. So we talked about AR and how it looks like. What about data, right? Our real-world AR app won't have just static monster rendered out there from the file system, right? We will have a bunch of data brought to our app, and we want to render this data. And actually, the talk name is data-driven AR apps, right? So how do we bring our data in? So we will do this with GraphQL. How many of you have heard about GraphQL? How many of you are using GraphQL? Nice. So you should use GraphQL, all of you, and I hope I will give you a better solution today how even to move your existing stack to GraphQL without writing everything from scratch. So what is GraphQL? In a nutshell, query language for your API, and some say it's magic. It's not really magic, it's just a spec, which is really logical one. The idea is you request from the client data in specific syntax, specific format, the shape of data that you get is the same data. Have one endpoint. You don't have lots of endpoints as in REST. And the thing that you do, you just send a post request with a query variable inside body with stringified format of this GraphQL syntax. Server defines a schema on the server and defines what are type relations between entities, how they are connected, and how the data is resolved. Now, the data can be resolved from REST endpoints, the data can be resolved from SQL databases, from NoSQL database, from anything you want. It can be just a variable that is returned. So it's up to you to implement that. And so GraphQL is not a library, it's a spec, and you can write a server in any language that you prefer. Most of them are supported. There are different libraries for each language, obviously. And on the client, we mostly use Apollo client to write GraphQL queries because it gives you a bunch of caching solutions and bunch of abstractions that you will need in real-world app. Now, this is a simple case of GraphQL. This is a more complex case of GraphQL. You have reusable blocks called fragments, and you can have variables that you pass to your queries. And the whole idea here is imagine that thing. So it's really simple to achieve that with REST. But what if I want to get bunch of data from like 7 different REST endpoints, right? So at some point I will have chaining request, I will have overfetching of data when I get too much data than I actually need. I will have underfetching data, and it will be pretty bad for your app, and especially for a mobile app, because of low-end devices, and you don't want to get onto like eat the whole mobile plan of your app user. So we will talk about how you build GraphQL backend with Hasura, and this is the company I'm developer advocate for. And Hasura is not a product that you need to pay for. It's an open source and free engine. So basically, with zero money, you get something cool. We will see how it's done. The idea is, if you have Postgres database, even with existing data, you can run the engine on top of this database, and the engine will generate GraphQL API for you without writing backend code, which is pretty nice to migrate your existing stack to GraphQL. It's nice for getting started with GraphQL, and in general, it kind of takes away 3, 4, or 5 months of your backend team work to implement a robust GraphQL backend. In terms of performance, it supports subscriptions out of the box, meaning WebSockets, and it can support 10K concurrent subscriptions per instance. So you can scale it kind of infinitely. Now the features it's not a hosted thing. It can run in Docker container, and you can understand that what runs in Docker container can basically run anywhere. So you can run at any cloud or locally. It's compatible with all authentication solutions. It can run, I already mentioned, on top of new and existing Postgres. It also supports Postgres add-ons such as PostGIS, TimescaleDB, auto-generates GraphQL API. In addition to that, it has kind of UI console, and it has also CLI that will help you to create things for CI, like migrations and stuff. It can work with custom SQL statements. So whenever you create a view in Hasura console, like a SQL view, you will have GraphQL query and subscription automatically created for you. And it has configurable access controls for data. It can be connected to your GraphQL server, which is important because you want your business logic, right? So in addition to that, it has an eventing system. How many of you know what Redux is? So this is like Redux for architecture. meaning whenever I have a state, this state is in database, so I write something into database immediately. When I write something through executing mutation to GraphQL endpoint, when something is written to database, this will execute an event which I can connect to serverless function, which can do everything that it needs, and it will change the state in the database, override the state in the database. So it's kind of bringing this business logic out to be more in a synchronous way. So how we create GraphQL backend for our app, and let's see if this will load. Okay, this is different slide. So yeah, you can go to Hasura, click on get started with Heroku free tier, deploy to Heroku, and you're basically done. This is just like for playing around, and you can do this after the talk and the break, and you will see how it works. So what we have, okay, this looks like it's loading. Yeah. So whenever you create your app, you will see something like this. So this is the Hasura console, which gives us graphical web ID that's sort of like Postman to GraphQL. I can execute queries, mutations, subscriptions here, and it will simply work. I also can go through the docs here, see what's available. Now the data tab will have a view into my database, how stuff looks like, how the things connected with each other, and I can add permissions on top of that. I can set different relations, and I have a bunch of data here, markers and model resources, and we'll see in a bit what this data all is about. Remote schemas will give me an option to connect to my custom server or custom resolvers. An event will execute serverless functions based on database updates. Now, this is pretty much the same that I just told you. So what is this data all about? And we will go into another demo, and we'll see how this will work. So I have this AR demo app, which is also relies on network. So I think I also need to connect to mobile, the hotspot, or I will, you know what? I just simply remove the Wi-Fi, and we'll see if okay, it loads. Pretty slow, but forgive me for that. But what I have here, I have 3 markers. Third is still loading. Connection is slow, so no, that's fine. So what marker gives me? So if I click on the sticker that I have, no, actually on my business card that I have. Basically, what I can do now, I can look at the business card, and it will load content inside, right? So pretty nice addition to business card. So in addition to that, I can load something different than just text. And the text you've seen was arranged on the screen by using Flexbox. Now the other thing that I can do, actually I need to wait for a model to load. I will have an alert box here. Models loaded. And now I have a car loaded on this marker. Now this data is brought using GraphQL, but I want to show you something cool here, and I will, let's do it that way. So the concept is called portals, and the idea is it loads portal in front of me. So let's just step into the matrix. Now, if I look back, I can look into the real world, and I need to rush because it can close and can just be stuck there. Not really, but we will do something fun. We talked about subscriptions, right? So let's actually change the world while the person will be inside this AR world. Benji, can you help here for a second? So I need you to be stuck in another world. Okay, that's fine. Come over here and just hold the phone. And what we will do now is we go to our. Let me just bring both of them so you will see something like that. So what we'll do now, we'll take an image of Hawaii. Do you mind going to Hawaii? Yeah. Okay, so what we'll do, we'll go into portals here, and we will change portal media into a different image. And we'll save that, and we'll wait. I mean, it's teleportation, so it takes a little bit of time, and also connection is not that good, but you can look around until you reach the Hawaii.
Not in Hawaii yet.
Not yet. But now you can enjoy the beach and
This looks nice.
yeah, and you are stuck. No, just kidding. You can get out. Now, do you mind holding it still for a second?
Yeah, sure.
Just give it for a second. Come on here. What we will do now is we will change using subscriptions. We will change the content on this card. Now, do you mind to hold it? Okay. So, what I will do here, I will go to my markers, and I believe this marker is this one. And what I will change here, actually, for the user, I have lots of users, so let's see, go into the marker, view the actual user, and for the user, we will change, we will add one. As you can see, one was added, and when I save, it's removed. So this is subscriptions going through WebSockets into AR world and doing and updating our app. Thanks, Benji. So let's see how it can be created. Now, yeah, let's look at the code. The code is loading. Cool. So, in order to write GraphQL, I need a bunch of things. I will need a GraphQL tag, and I will need React Apollo. My subscription is defined here. I define subscription as getting markers with a bunch of data, right? Now I just render them on the my screen, so nothing yet here. So this is that screen, and nothing yet into inside AR world, right? So just regular React Native code. Now inside I render mark item component, and I have navigate to AR function. This function, whenever you click on the marker, will navigate you to a different scene. Now the scene will be used here, get AR view, and it will use Vero AR scene navigator. Remember the one we've seen in for AR monster demo? So the same AR scene navigator. Inside we'll have scene with bunch of props added. It's the same scene, but used for either portals or for the markers. Now the marker scene will have a direction light, and will have a Vero node. Vero nodes, you can think about that as view in React Native, as div, as anything that you like, as a container that you can align anyway, anyhow that you want in AR world. Now you can notice here I still have I have subscription here too, and I get my marker. So whenever my subscription will be pushed from the update will be pushed from WebSocket down to the client, it will be updated also in AR world. Now the image marker, it's specific to Vero, a component specific to Vero. It gives me an ability to scan any image that I want, and whenever the anchor is found, meaning that the image itself is aligned in 3D world, in AR world, I can render anything on top of it, whether it's 3D content, 2D content, anything. I can also register animations, animations that you've seen with the business card of data just going out from the like my name and Twitter profile, just sliding out from the business card. This is just regular animations that you define here. Now to run animations, I just use the animation name and run them based on my state. And the flex view that I already mentioned like 4 times or so, you can use it to align your 2D content into inside the container to align it using Flexbox, which is a pretty nice thing that you can do that without playing around with the different positioning in 3D world. Now, if I have a 3D marker, which was the case with the car, I can render a 3D object, which is not different than that AR monster that you've seen. It's the ambient light and the marker and the model component. You can imagine that model component will have Vero 3D object, and that's about it. You see the Vero 3D object. Now the problem though that I need to create this model on the fly, so I need to download these assets instead of having them on device. So that's why whenever I render my model component, I check the resource type and if it has OBJ, MTL, and do different bunch of things here with the URI resource. Now Vero can support loading OBJ models only through the network. So in case you have more complex models such as FBX, more like skeletal models and skeletal animations, you will probably need to save them locally on the phone and then load by different key or something like that. But OBJ models is pretty fine for almost any app, any commercial app that you will create for AR. Now to register animations, I register the scale model animation and I check bunch of properties inside. So yeah, that's about it. So for portals, I also do a subscription. So pretty much the same, right? I have a subscription. I fetch portals. I have ID portal media 360 and thumbnail image. And whenever I updated that in Hasura console, Benji was teleported to Hawaii, right? So teleportation is pretty easy with the GraphQL. So you have a subscription component, and pretty much I'm going through the same code. So I hope you get the idea how this can be done. Now, going forward, what types of apps you can create today, right? So obviously you think about like, okay, this 3D world, I have to specify all these values in as a vector, need to calculate all of those, and I don't have visual representation how they look, and it can be complex. I won't lie to you, it can be complex figuring out where is the model and how to anchor it to the world. But let's say we don't create every AR app in React Native. In fact, we create data-driven apps, AR apps, which are not games, and mostly of like rendering 2D contents or rendering simple 3D content in the real world using React Native. That's fine. But if you have a game in mind, probably use Unity, probably use Unreal because of the visual representation of what you want to create. Now, if you want to create something that like store app, right? Store app will probably have a list of items in your store. Like, think about IKEA store. Have a list of items, you click on each item, you have the item can be loaded in the real world. This is pretty much the same I did with the markers and the car and the AR monster. The difference though is just the difference only is just the scale. But as soon as we are connected to backend, we load our data through GraphQL from Postgres. It's fine. You can scale it infinitely. And in addition to that, if you have serverless functions as a business logic, you can reduce the cost to almost zero for huge app. Location-based AR is pretty popular nowadays, and the idea is you're walking down the street, you just point your camera and you see the name of the store, or you see the, well, you can read the name of the store honestly, but you see the more data on the about the store, about the location, maybe about museum installation. You go into a museum, you have a AR app, and based on your location, it will render in which historical installation, in which hall you are into. It can render navigation whenever you walk. So let's think about airports. You walk through the airport and you don't know where to go, and you have all these signs, and you don't like let's say you're in China, you have all these signs, you have everything is in Chinese, you don't know where to go, and you pull your app, and you will see the camera. On the camera, you will see an arrow pointing to the where you actually need to go. Games, well, games it's pretty obvious. You can go to App Store or Play Store and get a bunch of AR games even today and play with them. Retail apps is the IKEA example I told you about. Indoor navigation, which is used mostly for airports, but sometimes also used in museums and such. For tools, you can measure things pretty accurately in AR. You won't get to the point of like a couple of centimeters, but measuring your flat and creating 3D model out of your flat, there is an app on App Store, you can do that. Visual assistants, this is more dominant with Microsoft HoloLens or hand-mounted devices. The idea is you look at something and the person is connected on the other end, and the person will see the same result that you see in camera. He will draw arrows like, please turn this knob to the right instead of to the left. Stuff like that. This is also pretty common use case for real-world apps. For traveling, going into the new city that you don't know and having this AR virtual tour through the city can be a pretty nice experience. Imagine that you go through the city based on location, based on where you are. It will give you an option to see a video clip about the specific location, and it will be just in front of you in the real world. So you won't be distracted by just looking at your phone. You will see both the clip and the location that you're into.
I'm sorry, unfortunately we're out of time.
Yeah, and we are on the last slide.
Oh, sure. Great. Sorry.
Yeah. So yeah, I was about to say and much more. So if you want to learn more about GraphQL, we just released several days ago learn.hatsura.io. It's a website that contains 2-hour courses in all major technologies for front-end, mobile, back-end, and has videos. A bunch of things are coming also, like Angular and Flutter and stuff like that. And thanks a lot for attending this talk. This is my website, my Twitter handle, and 3 repos down over there. These are 3 examples that I showed you. The first one is the one with the markers, the second one monster, and the third one with the Tetris. Thanks a lot.